Hey everyone, we are going to work on two lessons today. This is 10-2 and 10-3. So if you missed one of those days, you can fast forward to 10-3 if you need to. All right, so we are going to start on page 221 and we're talking about theoretical probability. So in 10-1, you were able to find out sample spaces of possible outcomes of what could happen. For instance, what's the probability of, or how many outcomes would you have of rolling a die or something like that, or creating, I think you created tree diagrams, you created sample space or a sample list, I'm sorry, and a table. So today we're going to put those outcomes that you discovered how to do yesterday, figuring out those sample spaces, and we're going to find out a theoretical probability of some kind of event happening. So we will be creating a ratio, which you guys know is a fraction, of the probability of some event happening. Whatever that event is, that's what we call our favorable outcome. And the total number of outcomes on the bottom, that would be your sample space that you worked on back in 10-1. So sample space. Okay. So we will still have to create a sample space. So like I just said, in 10-1, there were three different sample spaces or ways to create a sample space. You had a list, you created a table. I think tables are my favorite. And then a tree diagram. Ooh, I like those two though, so who knows? Okay, so today we're going to use that sample space, so we'll still be finding the sample space to come up with some kind of probability. So we have the spinner over here. It is going to be spun twice, and we want to find out the theoretical probability of spinning the same number twice. So we would create our sample space just like we did in 10-1, and that's what they've done here. Okay, you could spin a 1 the first time and then a 1 the second time, etc. There are 16 possible outcomes. We want to find the theoretical probability of spinning the same number twice. So when I'm looking at all these outcomes, I can just circle all the ones where the number occurs twice. And that happened 4 times out of 16 times. So the probability of the same numbers is 4 out of 16. That simplifies down to 1/4. You can put it in your calculator for ABC 16. Click equal, and you'll get 1/4, or you can say, okay, what's the greatest common factor that goes into both of those? And that would be 4, so divide each by 4, and you get 1/4. You also need to know how to convert that to a decimal. You can do 1 divided by 4. It will give you 0.25. Or you can use that green button on your calculator and then the arrow at the bottom, and it will put it in decimal form for you. To change it to a percent, multiply that decimal by 100, or simply move the decimal place over 2 times. There you go. Okay. Let's try it with a fair coin. So we have a fair coin that is flipped twice. What is the theoretical probability of flipping heads twice? Well, we've got to come up with our sample space first. I like tables, so I'm going to do that. So I can have heads or tails with my first flip, or I can have heads and tails with my second flip. So heads the first time, heads the second time, heads the first time, tails the second time. Tails then heads, tails, tails. So my sample space is 4 different outcomes. What is the theoretical probability of flipping heads twice? Well, that only occurred 1 time out of that 4, so 1/4. And again, in decimal form, 0.25, percentage form, 25%. If I go too fast, please pause. We've had some, like I said, some technical difficulties, so this is like the 3rd time I've done this video. All right. Example 2. We have a spinner that is spun twice. Notice that there are 10 pieces in that circle. We want to find out the probability that the number 10 will be spun twice. So I know that the probability of that would be only 1 time that could happen out of all the possible outcomes. So if I use that fundamental counting principle, 10 outcomes the first time, 10 outcomes the second time, so the combinations would be 100 total outcomes. Okay, and again, there would only be 1 possible outcome for spinning a 10 twice. I like method 2 the best. The probability of spinning a 10 the first time, so I'm looking right here, would be 1/10. The probability of spinning a 10 the second time would be 1/10. When I multiply those together, 1 times 1 gives me 1. 10 times 10 gives me 100. So I get 1 over 100. So the probability of spinning a 10 twice is 1 out of 100. Take that in your calculator. 1 divided by 100 gives you 0.01. Move that decimal over twice or multiply 100, and that is a 1% chance of spinning 10 twice. Okay, so this example here says, refer to the spinner in example 2. What's the probability of spinning any number twice? And give our answer as a fraction, a decimal, and a percent. Well, if I can spin 10 twice, only 1 out of the 100 times, that means all the rest of them are only going to double one time. I'm only going to have one time where I'm going to have spin a 1 and then spin a 1 again. I'm only going to have one time where I'm going to have double 2s. Double 3s, double 4s, okay? So there are 10 options to get doubles. And our sample space is still out of 100. If you want to kind of work out the table, you can. You can do a table where you do the number up to 10 for the first spin. It's going to get messy, so I'm not going to do it here. And then, see if I can do a line there, and then same thing for your second spin. And you see that there's only one chance of spinning a 1, then a 1, and then etc. So like I said, you can come up with a table yourself if you would like to do that. 10 over 100 does simplify down to 1/10. And in decimal form, that would be 0.1. Multiply that by 100 or move your decimal place over twice, which would give us 10% chance. Okay. Flip to 224. On 224, we have another spinner, but there's only 8 different sections here instead of 10. It says, what is the probability of spinning an even number first and then the number 5? So the probability of spinning an even number is 1, 2, 3, 4 chances out of 8. And that does simplify down to a 1/2, but we'll leave it as 1/8 right now. And there are how many chances of spinning a 5? Well, the 5 only occurs one time out of all 8 sections. So that is a 1 out of 8 chance. Go back to blue. And we will multiply that across. We get 4 out of 64. Okay, so I'm going to kind of come down here. I was actually doing step 3 there. Okay, so that's what we just did right there, and we got 4 out of 64, which simplifies to 1/16. Okay, for our little example here, try to do this on your own. We are trying to find the probability of spinning an odd number, then an even number. So same spinner. I'm going to go ahead and just write the numbers right here. Probability of spinning an odd number would be 1, 2, 3, 4. So 4 out of 8. Probability of spinning it even. 1, 2, 3, 4. Also 4 out of 8. Multiply those together and we're going to get 16 out of 64. And that would simplify down to a 1/4. Now, I didn't tell us what to put our answer in, so I'm just going to leave it as a fraction. Okay, so again, I know I might be going a little bit quick. Just pause whenever you need to. The homework for this lesson is on page 227. You are to do the front side, 1 through 8 all. I want to go over number 2 with you. Make sure that you read the directions to find out how to express your answer. So 1 and 2, you need a fraction, decimal, and percent. Round to the thousandths if necessary. And remember, the thousandths is 3 places after the decimal. Okay, so the probability of spinning a 1, oh, not spinning a 1, it's a 1 on a number cube, is 1 out of 6 chances with a number cube. And then a prime number. This is the reason why I wanted to do this one, because a lot of people have forgotten what a prime number is, and that's totally understandable. So a prime number, let's see, I'm going to write down all the numbers on a number cube. 1, 2, 3, 4, 5, and 6. So a prime number is a number that is only divisible by itself in the number 1. Okay, so for these numbers, 6 is not prime. We call it composite because it is divisible by 6, but it's also divisible by 2 and 3. 5, however, is only divisible by 5 and 1. 4 is divisible by 4 as well as 2. 3 is only divisible by 3 and 1. And 2 is only divisible by 2 and 1. 1 is kind of special. It's not called a prime number. So there are 3 out of 6 prime numbers. So we would multiply that, and we would get 3 over 36. You need to write that as a fraction. Go ahead and simplify it. Change it to a decimal, then a percent. I also found that number 7 might have given some people some difficulty. We have to find the probability that 2 numbers have an even sum. Okay, so I'm going to spin the spinner twice, and we want to find out how many of those combinations will give me a sum of an even number. So only way I can think to do it is I'm going to make a list or a table or a tree diagram, but I'm going to stick with list. If I spin a 1, the second time I spin can also be a 1, or a 2, or a 3, or a 4. Then I can spin a 2 the first time, get a 1, a 2, a 3, or a 4. I'm going to do this also with 3 and 4. Okay, so how many of those, if I add those 2 together, give me an even number? Well, 1 plus 1 gives me 2. 1 plus 3 gives me 4. These are even. That'll give me 4. That'll give me 6. This will give me 4. This will give me 6. This will give me 6, and this will give me 8. So I had a total of 16 combinations there, or possible outcomes, and 8 of them would sum to an even number. Okay, I'm going to let you do the hard part, which is to simplify it. Haha, joke. Because it does ask for your answers to be in a simplified fraction. Okay. Now, this is 10-3. So in class, we actually did this on, I believe it was Thursday, together. And we didn't go over the lesson part of it. We just went straight to the homework because the lesson part was a little bit kind of confusing. Anyway, what we were doing in the last lesson in 10.2 was finding the theoretical probability of an event. So that is mathematically what should happen. Here, we're actually going to have some experiments that were already conducted so we can see what actually happened. So theoretical probability, what should happen. Experimental probability is what did happen. So for exercises 1 through 4, we have the table over to the right. It shows the results of 500 experiments. Each experiment involved one person choosing from a card, or choosing a card from 2 identical decks labeled 1 through 5. All right, so before we get started, let's take a look at what we have here. So I have a deck of cards that have a 1, 2, 3, 4, or 5 in it. I have a second deck of cards that also have a 1, 2, 3, 4, or 5 in it. Somebody went through 500 times, picked a card first, then picked another card, and then tallied up the results. So what we're looking here, let's see. If the guy picked a 5 the first time and a 3 the second time, how many times out of 500 did that occur? Well, I'm going to look to see where those two intersect. So that actually occurred 18 times where the experiment, the guy picked a 5 the first time and a 3 the second time. If I add all these numbers up, they should give me a total of 500. All right, so what is the experimental probability of a person choosing a 2 the first time? And so that was supposed to be my highlighter. A 2 the first time, and then a 3 the second time. Okay, so they intersect right here at 20. So the experimental probability is that occurred 20 times out of a total of 500. Okay. Your job is to express the answer as a percent. So you can divide that, which is what I would do. Divide that out and then multiply by 100 or move your decimal over. So I simplified it first, so that was actually going to be 1 over 25. Somehow, my brain is not working. Yes. 1 over 25, and in decimal form, that would be 0.04. Move that decimal over twice, and you get a 4% chance of that happening. In class, students did 2 through 4 on their own, but they also had me here to help. So I'm going to do another one with you guys. I'm just going to pick number 3. What's the probability of choosing a 5 and then a 3? Okay. Well, that looks to be 18 out of 500. That will simplify to 9 over 250. And when I do 9 divided by 250, that gives me 0.036. Move that decimal over twice or multiply by 100, and that gives me 3.6%. Go ahead and finish numbers 2 and 4. Okay, 4, 5 through 8, we have a bar chart over here, and we have 200 experiments. Each experiment involved a person rolling 2 fair number cubes and then recording the sums of the values as shown. So for instance, they threw 2 die. It landed on a 3 and a 4. So they added the 3 and the 4 together. That gave them a sum of 7, and that would have been calculated in that number up there. All these numbers up top, they are all going to add up or sum to 200 experiments. So 200 is going to be your denominator on all these. All right, so what is the experimental probability of a person rolling a sum of 4? So there's my sum of 4 right there. How many times did that happen out of the 200? It happened 15 times. Okay. These questions want us to put our answer in the decimal to the nearest thousandths, which is 3 places after the decimal. So when I take 15 and I divide by 200, that is going to give me 0.075. That's already to the thousandths. Okay. Number 6 should be just like number 5. Number 7 is a little bit different. What's the experimental probability of a person rolling a sum less than 7? Not 7, but less than 7. That means they rolled the die and they got a 6. They could add them up and they got 6. They could add it up. They got 5, 4, 3, or 2. So we're looking at just these numbers right here. So how many times did the person roll a number or 2 die that added up to be less than 7? Well, it is all of these. Okay, so 5 plus 9 plus 15 plus 21 plus 25. All of that divided by 200. So when I add up all those numbers in the numerator, I came up with 75 out of 200. 75 divided by 200 is 0.375. Number 8 is like that as well, but you're looking for a sum greater than 9. All right. Good luck, and I'll see you guys soon. Oops.